Okay, good afternoon, guys. Good afternoon, learners. There's a question that is asking on how to calculate bond energies. Ne? A lot of us might be having problems with calculating the bond energies. I know we all have our notes and we are sitting there and staring at them and wondering what on earth is going on. So, let me see if I can break it down for you guys. So we are doing bond energy calculations. Ne? What is bond energy? Bond energy defined in our notes. Bond energy is the energy needed to make or break a mole of a particular bond, which means our unit of measurement will be in kilojoules per mole. The reason is we would like to know, or we would like to say, when we're doing chemical reactions, we are mixing two chemicals together, whether they are in gas form, in liquid form, or whatever it is. And we know that the best way to calculate energies and best way to get exact calculations is when we are using the smallest units, which is our moles. So then, in the example that we have there, we have two hydrogens reacting with oxygen to form a water molecule. Ne? Hydrogen burns in the air to form steam. Calculate the energy change for the reaction. Now, first things first, the first thing that we need to do is we need to write down the reaction. Ne? We have written down the reaction, that is step number 1. Ne? Step number 1, we've written down the reaction. Secondly, we need to identify what we're looking for. We want to calculate the energy change. And in our notes, we have delta H, or energy change. Ne? Its calculation, or its formula, is the sum of bonds broken minus the sum of bonds formed. I know here there is no sum, but add it there and say the sum of the bonds that are broken, and then you subtract that from the sum of the bonds that are formed. So basically, you take your energy that is produced on your reactants and you minus the energy that is formed by your products. Ne? So, what did I say? Step number 1, write the reaction. Number 2, write down the formula for what you want to find for that specific question. Step number 3, now you need to identify what are your bonds broken and what are your bonds formed. Now from this, you can already see that there is a hint there. Ne? I already gave the hint. Your reactants is where your bonds broken will be. Ne? You're putting two things together, so therefore those bonds are going to be broken. And then the bonds that are formed will be on your product side. Ne? So that is step number, I don't know which one it is, but that is the next step that you identify. I've lost track of counting. So then you identify your bonds broken and your bonds formed. Ne? And you write them down. So that means this side and that side. Okay, so now you have your reactants. Ne? Two hydrogens reacting with oxygen. Ne? To form your water molecule, or your steam in this case. So now we know we've done bonding, right? We know our hydrogen atom, how does it bond, right? It bonds by this way, ne? And we know our water molecule has a double bond, ne? So according to our different types of bonds that we have, we will always be given this table over here. It will be in your test papers. It will be in your exam question papers. Ne? This tells you the types of bonds have a specific average energy. Ne? This is the average energy of these types of different bonds. And these are the common bonds that you will be using when you are doing bond energy calculations. So then we have identified two hydrogen, two oxygen. These are the types of bonds. Ne? Hydrogen, that type of bond. So then we go to our table. We see hydrogen, hydrogen, and that energy is 430 436. Now here we said 2 hydrogen atoms. So that means we need to multiply the 436 times 2. And then our oxygen molecule, remember it's only 2 oxygens. It's only 2 oxygen if it's written like that. Then we have 2 oxygen molecules. But if you have it as just this, then it's just 1 oxygen molecule. So therefore we go back to our table and we can also see there that is the energy for that one. So now we sum it up. When we're summing it up, we're adding it together. So we sum it up. We say 2 times 436 plus the 498 gives us this number, 1,370 kilojoules per mole for our bonds broken. For our bonds broken, this is the energy that we have. So which means we already have the first part of this formula. We said it's 1370. Don't leave out your units, kilojoules per moles, minus now we need to find our bonds that are formed. And we said our bonds that are formed are on our product side. So product side is the water molecule that is formed. The water molecule that is formed. And now we need to identify the type of bond that we will have here. Usually we know the linear bondage. The linear bondage is hydrogen bonding to oxygen, oxygen bonding to. So that is the linear bondage for our hydrogen molecule. When we talk about organic molecules, we'll start talking about tetrahedral and hectahedral and all these things, but that is, don't worry yourself too much right now. But we know that from our knowledge, this is the bond that we have for our water molecule. And then we go back to our table. Do we see a bond that is like that? No, we don't see a bond that is like that. But we see something similar to that, right? This part. This part. This part is in our table. And it is the first one. So now it says 2 of these. 2 of these. So that means this 2H2O. So 2 of these. So that means we'll have 4 molecules in total. That means we'll have 4 molecules in total. So what do? It's simple. Here's our bond. We multiply this bond 4 times. So it's 4 times 4, 64. This gives us this number. So this is the energy calculation for our bonds formed. And now we can plug it into our formula. Here's our final formula. 1370 kilojoules minus 1856 kilojoules per mole. And this will give us a negative number. This being a negative number means that this is an exothermic reaction. I really pray and hope that this helps. If you have any more questions, you're more than welcome to ask. But I hope that this helps. Thank you. I'm patiently waiting for more questions.